Yay!
Yay! Okay, we mentioned that the smallest moment of inertia is going to be around an object's center of mass. So for some simple compound object, let's prove it. So here's a simple object. There's a little m and a big M, and then let's just take the moment of inertia around some point, x, right there in the middle somewhere. Not exactly in the middle, but just some arbitrary point x. Okay, so what is the moment of inertia? The moment of inertia is the sum of each mass times its distance away from whatever point we're interested in, squared, right? So, okay, let's do it for this object. I'm going to have what it's going to be m times x squared plus. Now I'm going to have a big M times, how far away is big M from that point? Well, if the whole thing has a length of L, then the distance of M away from that point is just going to be L minus X. And then I'm going to square it, right? So there we go. That's the moment of inertia. What we're interested in is, where is the minimum? Well, the minimum is going to be where, just from calculus, what we can do is vary the position x a little bit and see where the derivative is going to be 0, right? So from calculus, what you do is you take the derivative of the function. It's a function of x. It's the x that we're trying to vary and find out where the minimum is. So we're going to take di dx and set it equal to 0, right? That's how we're going to find this thing. All right, so I know what I is. So let's take di dx. So this means that 2m times x plus, let's see, m L minus x squared. Okay, so that means I'm going to take my 2 down. I'm going to have my m L minus x, and it's sort of a chain rule, right? So now I take the derivative of what's inside with respect to x. That's just a -1 from inside there. So what that means is, whoops, small eraser. So that changes that to a minus. And that's going to equal 0. That's the thing I want to have it equal to 0. Okay, so great. So we can cancel out the 2, and we're solving for x. And this position x is going to be where this thing is a minimum. So let's gather the terms together. So this means that x, I'm going to have a little m plus now a big M is equal to, bring that other term to the other side. I'm going to have m times L, right? Okay, so now I can solve for x. So the position where the moment of inertia is a minimum is just ml over big M plus little m. But look at that for a second. What is this point? I mean, suppose we were looking at this object and we wanted to find the center of mass, right? If we wanted to find the center of mass of this thing, let's say with respect to the left-hand edge, the center of mass is left end is the origin, right? Remember how we do that. If we wanted to find the center of mass with with respect to the left end being the origin, what we would do, this would be equal to m times 0. It's at the left end, plus big M times L divided by the sum of the masses, little m plus big M. But look, that is the point that we found. That is the center of mass. So we've done it. So we've proved that for objects like this, where is the moment of inertia a minimum? It's a minimum at the center of mass. All right, very cool. Now it's proved.